Okay, so let's take a look at number 4. It says Sasha spins the spinner below. If she spins it once, what is the probability that it'll land on E or G? So E or G, here's E, here's G. Each of them is on there once. So the probability of E or G, there's 2 numbers that we circled. Out of how many sections? 1, 2, 3, 4, 5, 6, 7, 8. 8. And since it's once, we know this is a simple event, so all we have to do is find the probability and simplify. So divide by 2, divide by 2. It's 1 over 4. So our answer is B. That one was easy peasy. Okay, I think I did that one in the previous video. So we're going to start at number 7. So number 7 says a container of bouncy balls holds 3 clear, 10 yellow, 3 green, and 4 red balls. A ball selected at random from the container. Which statement about selecting one ball is not accurate? So it wants not true or false, right? So we're looking for a false statement. So let's read A. It says selecting a green or a red ball combined is less likely than a yellow. So green is 3, or red 4, combined means adding. So that's 7 is less likely than yellow. 10 is yellow. Well, 7 is less than 10. So that's a true statement. It says selecting a green ball is equally likely to selecting a clear. So green is 3. Is that equal to clear? 3. Well, that's true. C says selecting a red ball is more likely than selecting either a clear or a green. So a red ball, 4, is more likely, so bigger than selecting a clear ball, clear 3, or a green ball, 3 or 3. So that's true. So let's look at the last one. Selecting a clear ball is equally likely as red. So clear 3 is equal to 4. Well, that's not true, so that's not accurate. That's what we're looking for. We're looking for our false statement. Okie dokie, moving along. Okay, so Miss Baird plans a party. For lunch, everyone makes their own pizza creations. So she has guests select a type of crust. So thick or thin. So I'm gonna think about that. Okay, so the pizza toppings, there's 1, 2, 3 of those, and a drink. So what is the probability that they randomly select thin pizza crust, pepperoni, and tea? So tea and pepperoni. So I have 2 options. I can do it mathematically. So I want the probability, it says of thin pizza crust, pepperoni, and tea. Or you can draw a decision tree. But let's do it mathematically first, and we can check that way. So thin. So thin is listed once, and there's 2 crust options. Oops, so 1/2. Pepperoni is listed once, and there's 3 options of toppings. And then the drink, tea, is listed once, and there's 3 options there. So now what do we do with our probabilities? We multiply them. So 2 times 3 is 6, 6 times 3 is 18. Okay, so we have our answer here. If you wanted to do it a different way, you could do your decision tree and say, okay, there's either thick or thin pizza. There's pepperoni, sausage, veggie, pepperoni, sausage, veggie, and then there's soda, tea, water. Soda, tea, water. soda, tea, water, soda, tea, water, soda, tea, water, soda, tea, water. So they're saying that they wanted thin pizza with pepperoni and tea. So remember, the biggest part of the tree is your number of outcomes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And we only circled one of the 18. So again, same answer, two different ways of going about it. Alrighty, so number 9 says the tiles shown below are arranged face down on a table. 2 tiles are drawn from the collection. The first tile is not replaced before the second is drawn. What is the probability of drawing the letter A and then drawing a letter C? And remember, it says it's not replaced, so A and then C. So let's start out with the probability of A. So there's 1, 2, 3, 4 A's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 4 out of 16 cards. So 4 out of 16, divide the top and the bottom both by 4 is 1 over 4. And it says it's not replaced. So I'm going to cross one of them out. And then it says the probability of the letter C. So there's 1, 2, 3, 4 C's. And then are there 16 cards? Well, no, we crossed out this one. We left that one out. So there's only 15 cards now. I can't simplify there, so I have 1 over 4 times 4 over 15. And I have 2 ways of going about this, okay? Some of you guys are comfortable with taking common factors out of the diagonal. You say this is 4, so 4 divided by 4 is 1. 4 divided by 4 is 1. So I multiply across. 1 times 1 is 1, and 1 times 15 is 15. Some of us are not as comfortable, so we say 1 times 4 is 4. 4 times 15, well, 2 times 15 is 30, so 4 times 15 is 60, and then we can reduce it by dividing the top. Well, let's say 2, so it would be 2 over 30. Then you can reduce again, right? Divide by 2, 1 over 15. So there's our answer. Okay, number 10. Amy rolls a 12-sided die numbered 1 through 12. And you know, I was really proud. I saw a lot of you guys that listed out your numbers 1 through 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so then it says, what is the probability that she rolls a number divisible by 3? That caught a lot of you guys up. It means divided by, or a number that can be divided by 3. Well, can 1 be divided by 3? No. 2, 3, 3 can, 6 can, 9 can, and 12 can. So we circled 1, 2, 3, 4 numbers out of 12 options, right? And we can simplify it by dividing the top and the bottom by 4. So we get 1 over 3. So we should know this and know that that 1/3 is 0.3 repeating, right? But if not, you did top in, bottom out. 3 doesn't go into 1, but it goes into 10 3 times. 3 times 3 is 9. Subtract, you get a 1, and it keeps repeating. All right, so our answer there was B. All right, so number 11. This one threw a lot of you guys off, so let's take a look. It says Jillian performs an experiment in which she spins a spinner with 3 equal sections, so we see that here, and flips a coin. She records the results in the table below. So here's the tricky part. Based on the results of the experiment. So The results of the experiment means what actually happened. So what's in this table? What is the probability she spins a green on the spinner and flips heads? So we're looking for green and heads. So here's green and heads. So that happened 6 times. And always on the bottom, we put the total. So we need to add all these up. So 7 plus 9 is 16. 8 plus 11 is 19. 6 plus 4 is 10. Make it a little easier to add, right? 9 plus 6 is 15. 1, 2, 3, 4. So 45. So 6 out of 45. So I know 45 is not even, so it's not divisible by 2. So 6 can be divided by 6 or 3 to simplify it. So let's see. I know 45 is not divisible by 6, right? Because 6 times 5 is 30. 6 times 9 is 54. 6 times 8 is 48. So that's not it. So let's try 3. So 45 divided by 3. 1 times 3 is 3. 15. 3 times 5 is 15. All right, awesome. So divide by 3. Divide by 3 is 2 over 15. Perfect. Next. All right, Jill had a ribbon 1 meter long. Jill and her sister, oh my goodness, this is tricky. Jill and her sister each cut off 0.2 meters of the ribbon. Okay, so Jill cut off 0.2 meters. Her sister cut off 0.2 meters. Okay. Jill cut off another 1/10 of a meter. So 1/10, I know that means it goes in the tenths place, so 0.1. So then Jill cut off another 0.1. What is the length that was left unused? So she used this. So let's find out the total they used. So we have our decimals lined up. We're ready to add 2 plus 2 is 4 plus 1 is 5. So 0.5. And we want to know what is left unused. So here's the 1 meter. They've used 0.5 and they want to know how much is left. So we should know mathematically that half plus a half is a whole. But just in case, 1 meter, 1.0 minus 0.5, you have to line up your decimal. Borrow 10 minus 5 is 5. So our answer was 0.5. So 0.5. Alrighty, good job, guys. Keep on correcting. Write your complete sentences.